Now let's talk about something that gets people riled up, right? This is we could do this upper one. We're just gonna skip past it. Let's talk about these next ones. These next ones are called Scott T transformers. And one of the primary uses was back in the day when they had Edison and Tesla arguments back and forth, and they had Niagara Falls with two-phase and four-phase systems, and how did they merge that onto three-phase systems? And some of the transformers back in the day were Scott T's for that. And so these are actually just two coils instead of three, and they're actually center tapped. You usually can't break out this center tap right here on that one coil. They're not brought out to a bushing like a neutral or anything. Okay, but how do you test it? Well, look, these are parallel lines. Okay, so look, they tell you right there, that was that one. And then let's use another color for our other parallel line. That's this one right here. And the only problem with this one is that we're going from H, we don't have a tap connection here, okay? So we actually have to find one. And that means we're gonna go down to here, okay? That's the only thing with this one, and just be careful, all right? Now, let's talk about, oh, and by the way, you could do, if you really wanted to, the other way, okay? And personally, I wouldn't say not to, okay? This would be H2 to H3, and then this would be X2 to X3. Is it really required? No, because you just verified it with these other ones right here, right? These other ones got verified already. So you're really testing the same stuff. But it doesn't hurt because nowadays they're used still as three-phase transformers, so it's good to show all three phases, right? This next one is the T is flipped, and what ends up happening is we get a 30-degree lag on the secondary, and so A phase is here, and here's little a, right? And so we're looking at different sections of the T, all right? Again, open up the document. It's got all right here. It's even got ratios for you right here, okay? The last one we're going to talk about is, like I said, when we're doing our other ones, these could be just 3 single-phase cans, okay? And that's the first point I want to show on this slide. Now, the real point on this slide is that these are all listed as additive on the top, and the bottom is listed as additive, and I'm going to write it in a different color, subtractive, okay? And so what is subtractive? Well, an additive coil is basically where you look at it, and this is H1, H2, X1, X2, and when you look at it, this is polarity dot, this is polarity dot. Now, when you look at a subtractive coil, there's 2 ways of doing this, of drawing it, okay? But they have the same meaning. And so this is H1, H2. This is my polarity dot. This would be polarity dot here, X2, X1. And you can see now my X2 has the polarity dot. Okay, and that's the convention, is to keep X2 with the polarity dot. When you were building auto transformers back in the day, you could actually put these in the primary coil and the secondary coil in series with each other, and you can get additive or subtractive voltages because of that. And so they just kind of kept the convention. Okay, and so this would be like writing with your X2 still on the bottom right here, and your X1 on the top. But the thing is that our polarity dot's on the bottom, and then on this one, X2's on the top. Okay, so does that make sense? Well, let's look real close at it. Okay, if you look, you've got H1 coming in on the left, H2 on the left, H3 on the left of each one of these cans right here, here, and here, right? And then let's look at our output. This says X2, well, X2 going out, X2 going out, X2 going out. Okay, well, these are all additive, so that kind of makes sense, right? They're all the same at least. Let's look at our other batch now. H1 going left, H2 going left, H3 going left. Those are all the same. So clearly they've done something with the secondary. And well, maybe what I should have done is draw all these in blue, so that way you can see where the subtractive comes from. So let me just do that real quick. Left, left, and left, and then left, left, and left X. Well, yeah, we'll do that one. And then, so if you look, these are the same. X2 goes out, X2 goes out, but you look, X2 over here goes out, but we've flopped the sides, okay? And that's all they're trying to show. They're just trying to show that the terminals are swapped, okay? It's really all they're trying to show. So hopefully this helps someone. Like I said, there's a lot in this one, and some of this is just a culmination of things that I've seen over the years and cool little tricks to help you when you're trying to troubleshoot a transformer. So thank you all.